AI just cracked a scientific problem that had stumped experts for decades. This isn't some weather app, we're talking about the fundamental building blocks of life, proteins. Until now, understanding them has been like trying to read a recipe in a foreign language. But this AI just decoded the code. What does this mean? Cancer cures? Climate change solutions? In this video, we will get into this scientific breakthrough and see how AI is rewriting the future, one protein at a time. Are you ready to have your mind blown? So be with me until the end to learn something shocking, and don't forget to subscribe to the channel first. Proteins. Seriously, they're involved in pretty much everything your body does. But for a long time, they've been kind of mysterious, something you don't really know much about. That is, until now. Enter AI, our trusty sidekick. So, what's the big deal? Understanding proteins means unlocking a treasure trove of possibilities in the world of biotech. For the past few months, our protagonist, let's call them the protein explorer, has been on a mission. They've gone deep into the world of proteins, scouring through data and research, all in the name of shedding light on this fascinating subject. And guess what? They're here to share the juicy details with you. Now let's discuss something cool, cancer-fighting proteins. But before we dive in, let's review the basics. These tiny guys are like shapeshifters on steroids. Seriously, the number of shapes they can morph into is mind-blowing. Humans have been trying to crack the protein code for over half a century. And let's just say it's been a bit of a roller coaster ride. We're talking about a puzzle so complex that even the best minds in science have been scratching their heads. Proteins are basically made up of these building blocks called amino acids. And guess what? There are 20 different types of amino acids to play with. Now, imagine you're at a Lego store with 20 different kinds of bricks. The combinations are endless, right? Well, the same goes for amino acids. Let's break it down. Say you've got a chain of just 3 amino acids. Sounds simple, right? Wrong. With 20 options for each slot, that's 8,000 possible combos, and we're just getting started. You can take these amino acid chains and stick them together like building blocks, creating a whole new type of protein. These proteins can then fold and twist into different shapes, like origami on steroids. Why does this matter? Well, these different shapes determine what the protein can do, each designed for a specific task. So whether it's helping your muscles flex or fighting off pesky germs, proteins are the MVPs of the cellular world. And guess what's making all this protein puzzle solving possible? You got it, AI. With its supercharged brain power, AI is helping us decode the mysteries of proteins faster than ever before. It's like having a cheat code for Mother Nature's instruction manual. Let's talk about diseases like diabetes and cancer for a second. See, proteins play a starring role here. They're like the perfect key for a lock, but with a magical twist. Imagine having a key that can adjust its grooves to fit any lock. Suddenly, millions of doors become accessible with just one key. That's some serious power, right? Well, proteins are in the same league. Think of the entire universe's timeline stretched out on a line, spanning a mind-boggling 13 billion years. Now take a protein and let it morph into different shapes, shifting and twisting every single day over the universe's lifespan. Even if you tried millions of configurations every day, you still wouldn't scratch the surface of the possible combinations for that one protein. Why? Because each protein can theoretically take on around 10 to the power of 300 different shapes. And out of all those mind-bending combinations, each protein knows exactly which shape to pick and gets down to business like a pro. Now, why should we care about protein folding? And how does it relate to diseases like cancer and Alzheimer's? Let's break it down. There's something off about this particular axon 1. It's folded incorrectly. Usually, it should look a certain way, but when it misfolds, it can lead to conditions like Alzheimer's. Now, let's talk about AlphaFold. Developed by DeepMind, a Google-affiliated AI company, AlphaFold swooped in. There's this annual competition called CASP, where teams worldwide try to predict protein shapes. Before AlphaFold came along, teams were scoring around 40% accuracy, which is decent, but not mind-blowing. Then, in 2020, AlphaFold strutted in and blew everyone's minds with a 92% accuracy score. We're talking predictions so close that the margin of error was tinier than an atom. Some structures were so spot on that out of thousands of atoms, only one was slightly out of place. Now, for the first time, the judges didn't just hand out a first-place trophy. They declared the protein folding problem officially solved. Thanks to AlphaFold, we've cracked the code on one of the biggest mysteries in biology. How did DeepMind pull off this protein folding wizardry with AlphaFold? Well, it's like this. They took a deep dive into the treasure trove of protein structures. It was a massive library filled with 170,000 different protein structures from various species. By studying this collection and paying attention to how proteins evolve across different species, they could start connecting the dots. For instance, if an amino acid tends to hang out in a particular spot across species, there's likely a good reason for it. Like if it's hydrophilic, meaning it loves water, it's usually found on the outside of the protein, where it can mingle with water molecules. But if it's hydrophobic, it prefers to chill in the middle of the protein, away from the watery surroundings. But DeepMind didn't stop there. It zoomed out even further. Imagine lining up two chains of amino acids on a grid, and then analyzing every time these two amino acids team up in existing proteins. It gave them even more juicy data on potential protein structures. Now comes AI. Just like ChatGPT can churn out sentences based on internet texts it's been trained on, AlphaFold can crunch through this data and start predicting how amino acids might come together to form new proteins. As AlphaFold receives feedback and learns from its mistakes, it becomes increasingly proficient at constructing proteins. So, while humans might scratch their heads and take ages to determine a protein's shape, AlphaFold can whip one up faster than ever. But how does that benefit us? First up, synthetic proteins. All the proteins we know from nature are like a cozy little box. But what if we could expand that box into a massive grid of possibilities? That's where synthetic proteins come in. We can design proteins tailored to tackle new diseases that nature's proteins just can't handle. Think longer, healthier lives, and groundbreaking medical treatments right around the corner. Let's break it down with some real-life examples. Ever heard of RSV, a nasty respiratory virus that hits infants hard? Well, scientists have made a protein combo that packs a punch against it, creating a supercharged vaccine with an A+ response rate. It could save millions of tiny lives. Also, they made a universal vaccine that takes on multiple strains of a virus at once, fighting off a whole army of baddies. Now let's talk cancer. Chemo can be like a wrecking ball, damaging healthy cells along with the cancerous ones. But with custom-designed proteins, we could deliver chemo straight to the tumor, sparing patients from the brutal side effects. Plus, with Denu proteins, we're talking about custom-made drugs tailored to each patient's unique needs. And this is just the tip of the iceberg. AlphaFold's breakthrough is like opening the door to a whole new universe of possibilities in biology and medicine. What's your opinion about this advancement of AI? Share with us in the comment section below, and don't forget to subscribe to the channel.